In this video, we will talk about statements and flow control in C++. A simple C++ statement is each of the individual instructions of a program, like the variable declaration and expressions that are being used in every single line of the program. They always end with a semicolon and are executed in the same order in which they appear in the program. But programs are not limited to a linear sequence of statements. During their process, a program may repeat segments of code or take decisions and bifurcate. For that purpose, C++ provides flow control statements that serve to specify what has to be done by our program when and under which circumstances. Many of the flow control statements explained in C++ require a generic or substatement as part of their syntax. The statement may either be a simple C++ statement, such as a single instruction terminated with a semicolon, or a compound statement. A compound statement is a group of statements, each of them terminated by its own semicolon, but all grouped together in a block enclosed in curly braces. Let's take a look at how these statements actually look like. So usually a statement looks like statement 1, semicolon, and that's what we get. When you have a compound statement, you're going to have more than one statements, and therefore you're going to need to enclose them in a curly braces. So basically this is what's going to happen. Statement 1 with its own semicolon, and then a statement 2 with its own, and a statement 3 with its own, and so on and so on. So it can go all the way. So you can have unlimited number of statements in here. As long as you have them between curly braces, that means you actually have a compound statement. So ignore the errors that you see over here, as I'm using my IDE as a text editor to show the exact look of the statements within the IDE. I get those later on when we have the right code, and those are going to disappear. So again, this entire block is considered a single statement composed of itself multiple substatements like 1, 2, and 3. And whenever a generic statement is part of the syntax of a flow control statement, this can either be a simple statement or a compound statement, as you can see here. So we're going to discuss more, and you're going to understand better down this video. So the first to begin with is going to be the selection statements, or something that is very famous as if then else or if and else. So the if keyword basically is used to execute a statement or block if and only if a condition is fulfilled. Let's go to the syntax and look at how we implement that. So let me clean up all that we have over here. So the basic syntax is you have the if statement, and then you add a condition, which is going to be tested for being true or false, and then you have your statement. So this basically is how this should look like. So let's do a real life example. So let me get rid of all these things. So I'm going to define an integer x, initialize it to 10, and I'm going to use the if statement. So if x is compared to 10, for say, and then remember, here you're going to need double equal signs to avoid the assignment error. And then in that case, just simply cout, let's say x is 100. And even make it nice. And that's pretty much it. Then, so x is 10, the condition is going to get checked. And because this condition is true, the statement after if is going to be executed. And that's all what we get. So let's compile this and see what happens. Okay, and as you can see, the output is x is 10. So let's make it in a way that the condition is not correct. I'm going to change this to 9, And I'm going to compile and run it again. And in this case, you see no output is going to be there since I haven't decided what to do with it if that is not the case. So let me just turn the condition back to true. The thing is, instead of just having one statement out here, you can have multiple statements. Let's say instead of just messaging out X is 100, you also want to tell them, thank you for putting in the right number. So basically what I need to do is to do another cout over here and send the second message. Let's just simply say second message. And as I'm kind of like OCD about this, let's make it good in the output. And in this case, right now, when the condition is true, this guy is going to get executed, and then this guy is going to get executed too. If I turn the condition to false, let me just go here and put 9 over here. The only message to be printed out is going to be this second message. And you can guess why, because that second message, and you see that now that it's compiled and running, and the only thing that I see over here is second message. Because when the control arrives at this if and the condition is false, it's going to jump over whatever it's supposed to do in that case of the truthfulness of this condition. So the next line to be executed is basically the cout. But what if I want the second message to be printed over there? Let me just, for the sake of this example, make this a little bit more descriptive and say this is an outside if block message. So basically, right now, if I execute that, and I'm going to do it, so you see it's going to print both of these messages which are actually out of the block of the if. So now I want to bring this second message into the block. So in case of the truthfulness, I want a couple of stuff to happen. In order to do that, what I do is I add the curly braces here, and actually I'm going to close it right after this guy. So now this cout, and let me just make it look nicer. Now this cout is a member of if block. So in this case, if I execute the program again, the only thing that you're going to see in the output is going to be this guy, and let's do it. And as you can see, only this message is coming out, and those two are jumped over. Now let's turn the condition to true, and if I run it right now, you see that now I have the X is 100, this guy, the second message over here, and then control is going to move to the out of the block message. So as you can see, this out of the block message is going to get printed out no matter what, because it is not even related to the if statement. So again, reviewing it, so you have if, which is the key statement, the syntax. Then you have a condition to be tested by the runtime compiler. And then you created a block which could have as many statements as you like inside. It can even either do a calculation, like if you want to see, if you want to assign an x++, you can do it right here, okay, and do it and print it. So that's actually a good strategy to count how many times you have come into this block and executed the block. That's pretty much a simple if statement. And let's take a look at how we can take care of something to happen if the condition is not true. So basically, we decided what to do when the condition is not true. So let's decide what we want to happen if the condition is not true. So the keyword is very simple. As you can guess, that's going to be the else. And let me just change this a little bit so you can see more. Okay, so now I have a full if then else block. So if the condition is true, whatever is here is going to happen. And if it is not true, whatever is here is going to happen. And I'm going to add a cout to this guy and say the condition is wrong. Okay? And let's make it nice and go from there. Okay. So now if I run it, you're going to expect to see the exact same thing with no change because the condition is true. So x is 100 is there. I'm going to get this one changed to the condition was true. And I know that I'm all over the place with is and was and all that, but just ignore it. The goal is to learn everything else. And let me just change this one. Pretty good. So let's run it again. X is 100, the condition was true, and this one is the outside the block message, which could be whatever comes after that. Now let's turn the condition to false and execute it again. This time you're going to see it says the condition is wrong. This is an outside message, so all of these already got ignored. So that's all about the if then else. So you have the syntax: if bunch of if condition bunch of statements, else bunch of statements, and the control decides to jump to these or to those and move away. The next type of statements that we want to discuss now are the iteration statements or loops. So loops repeat a statement for a certain number of times, or while a condition is fulfilled. They are introduced by keywords while, do, and for. So let's jump back to our IDE and start seeing how they work. I would like to start with the while loop. So the while loop has this type of syntax. So you have the while as keyword, and then you introduce an expression, whatever it is, and then you have a statement. So pretty simple. Oh, sorry, I just mischose. So just a statement, and there it is. So as simple as that, you can have a loop. So the while loop simply repeats a statement while expression is true. So it checks expression. If expression is still true, then does the statement. Which should ring a bell for you. You should be manipulating expression somewhere down the while, or you're going to stay in while forever. So if after any execution of a statement, expression is no longer true, the loop ends, and the program continues right after the loop. So let's go ahead for a real life example. So I'm going to define a control variable, integer n, or let's say x, and I'm going to assign it to 10, so initialized, and then let's do a keyword while, and now I need to put the condition. So I say while x is greater than 0, which right now is true. Let's do a bunch of stuff. How about that? Again, remember, you can either have only one statement here, or using curly braces, you can have a bunch of statements going down. And in this case, I want to see out simply just print x, and let's put a comma over here with space after that, and then do minus minus x, which, as you know, is going to reduce the x, and that's pretty much it. So let's run this code. So as you can see, it is counting x. X was 10, so the 10 is the first thing to be printed out. So see out x and a comma, which is this guy that you got, and then does minus minus x, which is decrementing the x, and the next step is going to be 9, 8, 7, and all the way to 1. And because at this point x is going to be greater than 0, the program exits. So as you can see, 0 itself is not printed out because x is greater than 0. So sometimes some challenge questions want you to print 0 in this loop too. And just think about it for a moment. If you set this to while x equals to 0, it's not going to run at all. So if you want 0 to be printed out, you can simply say if x is greater than minus 1, and then of course 0 is going to get printed out over there too. So One thing that you have to remember over here is, let me just check this. One thing you have to remember is you can have as many controller statements in here as possible. However, if you don't manage changing X, let's say if I don't put this over here, let's say if I get rid of this guy, then what's going to happen is you're going to have this loop to go forever. And this is one type of the logical errors that you may get into in your programming experiences. So be very careful that in the while loop, there's no exit unless this condition is going false. A very similar loop is the do while loop, whose syntax basically is going to be almost similar to our guy over here, the while loop. But let's get rid of these guys and say you should have do, and then you should have a statement, and then while comes to the play, and then you're going to have a condition. So that is the standard format. And let me just get rid of this for now. So this is the standard syntax for the do while loop. It behaves like a while loop, except that condition is evaluated after the execution of the statement instead of before. So when you're doing while, it evaluates the condition. If the condition is met, then it moves on. But in the do while, it does the job and then checks the condition. So you can guess in the previous example, just to print the 0, you could have used the exact same condition and do while instead of while. So that being said, let's go for example. So let's code the exact same thing that we did, but this time with the use of do while. So I'm gonna again define an integer x equals 10. So initialize the defined integer. And this time I say do, and what we want to do is we want to create that same output. So say out x, which is our parameter, and then for the formatting part, we will do this. So we're gonna decrease the x, and now we need a condition. So I need to have while, and remember what the condition was, x greater than 10. So we're hoping to get the same output as what's there. So let's compile it and see what we get. So as you can see, right now I only have 10. You can guess why, because the condition that I have here, x greater than 10, lets it only happen once. So this was an intentional error to show you guys that the condition is checked after the execution. So the x is going to get executed once and then checks the condition. And it figures, oh, it is not greater than 10. Because if you check this condition at the beginning, this condition is false because x equals 10, correct? So this condition is false to begin with. But the loop happens once because this condition is not checked before. It actually gets checked after our loop executes for once. And again, that is very important to remember. So to fix it and take it back to what it used to be, we change it to x greater than 0, and you can guess our countdown is going to be there. There you go. Everything is there. So again, if I put it back here, I'm repeating myself as this is very important to understand, as even though this condition is false to begin with, the loop goes once. Like even if I put 100 over here for distinguishment, you're going to see the loop is getting executed for once, the 10 is executed, then the condition gets checked. So use this ability in developing better and more effective algorithms. And this distinguishment between do and do while can help you a lot if you really think about it correctly. So the next loop that I would like to talk about, and let me clean out my workspace here, is the for loop. The for loop is actually designed to iterate a number of times, and the syntax for it is for, and then you have an initialization, which I'm going to discuss what it is, and then you're going to have a condition, and then you're going to have an increase, and then you're going to have a statement, and this is going to be your complete for loop. Of course, you have to ignore those errors. So like the while loop, this loop repeats a statement while condition is true. But in addition to the while loop, the for loop provides specific locations to contain an initialization and an increase expression. So it's executed before the loop begins the first time and after each iteration. So whatever you get in initialization and increase over here gets executed once before the loop starts and once after everything is done. Therefore, it is especially useful to use counter variables as a condition. So it works like initialization is executed first, so this guy gets executed first. Generally, this declares a counter variable and sets it to some initial value. This is executed a single time at the beginning of the loop. And then the condition is getting checked. If it is true, the loop continues, otherwise the loop ends. And then the statement is going to be skipped, going directly to the next step after the loop. Statement is executed actually when the loop is true, and it can be either a single statement or a block enclosed in curly braces, as we saw in the previous examples. And then increase is going to be executed, and then the loop goes back all the way to the condition to check the condition. Okay, so let's look again. Look at the steps. So the first step is going to be the initialization. The second step actually is going to be checking the condition. Oh, let me just get rid of these. I don't want to do this. So checking the condition, and then you have the third step, which is going to be execution of the statement. And then on step 4, you're going to have the increase, and you will have step 5, which is ending the loop. So 5 simple steps, and you're going to see it in action even better. Initialization, checking the condition, execution of the statement, increasing whatever, going back and checking the condition. If the condition is still true, going through the execution. Let's go for an example that is going to clarify what actually I was talking about. So I want to create a countdown using a loop. So far we did the countdown in the previous example. So we want to do the same thing. Let's see how simpler is that going to be. So for, I'm going to initialize my variable x now right here instead of having it at the beginning. And then I'm going to put a condition, which you remember the condition was x greater than 0. And then I'm going to decide how the decrementation is going to work. And now I need a statement, which is going to be cout x and the formatting parts of it, which you guys all remember how it looked like. This time, just to make it look nicer, I get out of the block and I'm gonna put a message out for this countdown, which is launch the rocket. Since this is a countdown, I think it doesn't hurt. Okay, Let's run this and let's see the result. So you can see now I have my countdown as it was before, and it is all working. So again, you will start with a condition, you start with initialization of your control variable. Then you check the condition of the control variable, you do the incrementation, and then you go for the block, whatever you want to execute after that. And that's as simple as it can go. So regarding the loop statement, I have to mention that all three fields in a for loop are optional. So they can be left empty, but in all cases, the semicolon signs, these little guys over here, are actually mandatory and they have to be there. Remember that a loop without a condition is a loop that has a condition which is always true. So it is going to move on and on and on and on, and you're going to be stuck within the loop. So a good programmer is the person who can use characteristics of a syntax towards the betterment of his code and effectivity of his code. So that's all about you, how to take advantage of that. So because each of the field is executed in a particular time in the life cycle of the loop, it may be useful to execute more than a single expression as any of the initialization condition or statement. Unfortunately, these are not statements, but rather simple expressions, and thus cannot be replaced by a block, which is so unfortunate. As expressions, they can, however, make use of the comma operator. This operator is an expression operator, as you remember, and can separate multiple expressions where only one is generally expected. So let's look at an example. Like if I can change this to, um, so I can say integer x equals 10, and then I can define another one like y equals 100 over here. And now as you can see, I have two initializations right there. And this time I say x minus minus, and at the same time I can do y plus plus. So as you can see in this example, you can have basically an initialization which is composed of two different small statements, or you can have the increase or decrease. Basically, we call this increase generally as the syntax is using that terminology. But anyway, you can have two different ways of doing it, and even under conditions, you can have more than one condition to be checked. So these are just for the sake of having specific solutions in algorithms, but it is always good to know those are available to you if need be. So now after this loop, we can move on and talk about a range-based for loop. Let me just clean up and go for a range-based for loop. This kind of for loop iterates over all the elements in a range, where the declaration declares some variable able to take the value of an element in the range. Ranges are sequences of elements, including arrays, containers, and any other type that is supported in the functions of the C++. There should be a beginning and there should be an ending on that range, and most of these types have not yet been introduced to you in the videos that I have produced so far, but we are already acquainted with at least one kind of the ranges like string as we discussed it. So for now, don't get confused with the string type when I'm using it in this example coming down. However, you're going to get introduced to different type of the data types and arrays and so on very soon. So let's start with the range-based for loop syntax. So basically it's going to be for the syntax, and then we're going to have a declaration, and we put colon, and then we're going to define a range. And of course, based on the truthfulness, we're going to go to statement and this is going to be the syntax that you use. Let me just clean this pretty quick. Yeah, good. So this is the syntax. Take a look at it, and now let's move on with an example so you guys can actually, I can keep this over here with this just in case you want to come back and look at it. So uh, in this case, I'm going to define a string. And if I want to define a string, I have to go up here and include something else. Again, ignore this because we're going to go through this in lots of more details in near future. So for now, just accept it from me. So I'm going to have string, and let's just name it string for the sake of this one. And I'm going to initialize it to hello. Okay, so now I have this fully initialized. Accept the syntax from me right now, as I said. Don't look for what is happening over there. And then now I'm gonna have my range-based loop. So for, and I'm gonna look at the character C and the string. So let's see what I want to happen. I want to see out. Let me just format it. As you know, I'm into having it nice and neat. And then I'm going to put C out. And then I'm going to close this to look even nicer. And that's pretty much it. And then let me just do one thing over here. Let's see out. And what I just want to do over here is to add a line to make life easier on myself. Okay, how about that? Let me run the program. So you see the results. It is a hello, but as you can see, the string is broken into the small pieces that actually compose a string. So what I did was the range that I defined was the range over the string. So my loop is going to go over this range and only this range. So whatever is inside this is going to be counted. So when it starts, this for loop is going to look at the character C. So basically character C is what I defined for my output. It's going to go through that, and it starts from point 1. In the first iteration, it reads the first character, which is H, uses the formatting I put here, and prints out H. Then goes to the second one, third, fourth, fifth, sixth, and so on and so on. This has in this example, I used a string. It could have been an array, or it could have been a list of numbers, or whatever, any type of data structure that we will go through in near future. Note that this loop is automatic and does not require the explicit declaration of any counter variable, and it does count itself. And when it gets to the end of the string of hello exclamation mark, it basically gets out of the loop and ends up. So that's another good thing about this type of range-based loops. They usually also make use of the type deduction for type of the elements with auto. Typically, the range-based loops can be written in different ways. For this one, and just for information over here, I could have done for auto character and the range of string, go ahead and see out the rest of the format. Let me just play my lazy game. So this basically is the same thing. I'm just cleaning up pretty quick. Yeah, this one is actually doing the exact same one that this loop on the top does. That's pretty much about the loops that we have. So let's move on to the next step, which is going to be the jump statement. Jump statements allow altering the flow of program by performing jumps to any specific location. Like if you want to go back to a location and continue control from there, or you want to send the control somewhere down the road and ignoring some lines, that's when you're going to use one of the jump statements. So we have the break statement, which breaks and leaves a loop. We have the continuous statement, which causes the program to skip to the rest of the loop in a current iteration. We have the go-to statement, which actually allows to make an absolute jump to another point in the program. And let's take a look at all three of them and see how the syntaxes are and how the implementation will be. So let's start with the break statement. So break, and let me just put it over here for you guys. So that is the keyword. So the break statement leaves a loop even if the condition for its end is not fulfilled yet. It can be used to end an infinite loop or to force it to end before its natural end. So let's create an example and see where we can go. So I'm going to create a loop for integer n equals 10, equals 10, and while n is greater than 0, then do the increment over there. And of course I'm gonna have this going, and I want to see out n with a colon at the end of it. And then of course I'm gonna put another condition within here, which is gonna be if n gets to be 3, which is good for n, then do something else within that loop, which let's say out countdown break, aborted normally, something like that, just to know that this is what we put in when we run it. And let's see what we're expecting to happen here. So if you don't consider this part that we added over here, oh sorry, let me just fix this pretty quick. There you go. So if we just ignore the part that we put another if within the if, basically what happens is the loop is going to count down from 10, which we saw what is happening. But this time, when the loop gets to be at the point of n being equal to 3, we basically are breaking out of it, okay? But this doesn't happen as simple as just having the C out over here. What we need to put in here is the keyword break, okay? So that completes the code. Let's run the code and see what we get. So as you can see, it counts from 10, 9, 8, 7 all the way to 3. And then it breaks over here with saying 3, and I can just even make it better by just putting a space over there. Countdown break aborted normally. And just to even make it a little bit neater, let me run it again. There you go. So that's simply how we break out of this for loop. So what happens here is the for loop starts counting and printing n, and each time that n changes through this decrement statement over here, this condition is being checked. Okay, if n is 3 at this point or not. And if n is 3, you have a message, and as soon as this break comes in, we jump out of the for loop, going to the last line over there. So it's pretty simple. There is another way to skip the rest of a loop in current iteration, and that's using the keyword continue. Let me go ahead and clean up our loop statement pretty quick. So we have a loop and we run it once again. So you see this is what we get when we run it in a normal mode. This time the statement that I want to put here is going to be if n is equal to 5, and then I'm going to simply ask the control to continue. And this statement that I just put in here should be right before the output statement, so it doesn't let the control to go to the output statement. And if I run this once again, you notice that number 5 is omitted from the list. What happens is when loop arrives at n equals 5, this continue skips the rest and goes back to the next level of iteration. So basically, next step of the iteration is going to substitute the current step, one step to be out. Pretty simple, omitting or removing just one step with continue. So the next thing, the next control that you can use is going to be the goto statement. So goto basically allows to make an absolute jump to another point in the program. This unconditional jump basically ignores nesting levels and everything and doesn't care where it's supposed to go for the next one or where is loop ending or beginning. It simply goes to the point that you're asking it to go. So remember, it's more like an absolute jump. For this matter, that it is an absolute jump, it is a feature to be used with care, and preferably within the same block of statement, especially at the presence of local variables and global variables, which we're going to discuss the distinction between those in future. The destination point usually is identified by a label, which is then used as an argument for the goto statement. And a label is made of a valid identifier followed by a colon. Goto is generally deemed a low-level feature with no particular use cases in modern high-level programming. So basically, when it comes to object-oriented programming, you're not going to see a lot of gotos happening. However, there are some very useful goto samples still being used by older C++ developers. So without any further ado, let's see how it works. So I define an integer like a counter for myself right now. And then over here, I want to define a label. The way I do the label is, let's call it LE label and put a colon at the end. And as you can see, the compiler automatically moves it to the left to show that's just a label. And let's do the same practice that we did so far about the counter one. Pretty quick, the same thing. And then now I'm going to go decrease it. And as you can see, I'm trying to create a loop over here without actually using the loop commands. So I'm going to check a condition with if. So if n is greater than, greater than 0, what am I doing? Oh yeah, that's my fingers using it. Okay, if n is greater than 0, then I'm going to ask the control to go to LE label, which I already have defined, okay? And then I'm going to see out, because the countdown is over, maybe something like Happy New Year, I don't know, whatever you use a countdown for. And move the control down. So basically what happens in this case is compiler is going to start with integer n10, see a label, okay, we don't deal with that for now, move on, print out the number, then decrement the number and check. If it is greater than 0, go to the label. So it doesn't move on to the Happy New Year. So it goes back all the way up to LE label, does the see out, and minus minus, and then again checks it. So that's just very simple, as you see, and I'm going to run it right now, and you see the result is going to be the same as you saw before. So as we said, it's going to be an absolute point to jump to, and it is a low-level feature, and as I said, it is not good for the modern high-level programming languages, but still sometimes it's going to be very helpful. I personally have the experience of using goto in the newer modern C++ programs to solve the problems that were really a headache to be solved without a goto. So again, be very careful. That's an absolute jump. It's going to go there no matter what is in the route. It's not going to do any check or anything. So your control is going to change to that point. A very useful selection of statements, which is used almost over all the programming languages, is called switch. So the syntax of the switch statement is a bit peculiar. Its purpose is to check for a value among number of possible constant expressions, and it is something similar to concatenating if-else statements and use them all at once, but limited to the constant expressions. Let's look at the syntax pretty quick, and for doing that, let me just clean up this over here a little bit to make life easier on us. And here is how the syntax work. So you put the keyword switch, and as you can see, it automatically gives you the structure. So you're going to need the expression here, right? And then you come to the case 1, case 2, case 3. So in this case, I want to just go ahead and say case constant 1. In case constant 1, then do your statement, whatever it is. It could even be a group of statements, right? And then after that, there's a break. Same thing, you can have case, and then you can have constant 2. And then again, the same thing can happen and happen and happen and again. So if I just copy this, I can paste it again and again and again with a different name, like this time constant 2, and go from there. Let me just clean this up and pull it down a little bit so we get more real estate. Yeah, as you can see, switch, the expression, and then different cases can come one after each other. The key is case constant 1 to do the group of statement 1, break, constant 2 do the group of statement 2, break, and so on, and go on. Then you have a default at the end, which actually goes for a default group of statements over here. Okay, so you can have a bunch of more statement over here. So it works in the following way. Switch evaluates expression and checks if it is equivalent to the constant 1, constant 2, or whatever other constant. If it is, let's say, equivalent to constant 1, then it executes the group of statements 1 until it finds the break statement. And when it finds the break statement, the program jumps to the end of the entire switch statement, which is here. Okay? So if expression was not equal to constant 1, it then checked that expression against constant 2. And if that expression is equaling to constant 2, these set of statements over here will be executed all the way to get to the break, and when the break is there, it's going to jump again to the end of the set of statements. Finally, if the value of the expression did not match any of the previously specified constants, like constant 1, 2, 3, and so on, there may be any number, there's no limit on the number of those constants, the program then executes all the statements that they come after the default. So pretty straightforward, and at the same time pretty amazingly to help you. Let's say you can say switch name of the student, case John, then say hello John, case Jack, then say hello Jack and break, and finally the default is hey, you don't have a name, I cannot find your name in my database, and something like that. Okay, let's understand switch along with an example. So I'm going to define an integer x for now, and then I'm going to use switch, which is going to be based on x, whatever the value of the x is, okay? And case 1, which means if x equals to 1, I'm asking a cout that says x is 1. Okay? And then of course I have to break because I don't want the rest of the switch to continue, okay? And then I'm gonna say case 2, and let me just make it look as I usually love it to be. Remember, readability of the program is important, especially when you want to debug it back. So case 2, what we want to happen, we want to cout, this time say x is 2. And that's pretty much what we need over there. We need to break out of it too. Remember the break, or your switch case is not going to really be useful. And then I want to say, what if none of these cases happen, which is going to be the default case. And I will be like, let me tell you that x is neither 1 nor 2, right? Which is the truth at this point. And I'm going to go ahead and finish this. So if I set x to 2, then and run it, and let me just pull this guy a little bit higher so you guys can see it. Then of course x is 2. If I put x1 and run it, it's going to go and only execute x1. Look at this case. X is 1, so switch is going to compare x with everything in the first case that I put. So case 1, this value is going to be compared to the value of x. If x was like, let's say 5, what happens is x is not equal to 1, so we're going to move over to the next case. X is not equal to 2, so we move over to the default, and the default is going to happen. Let's see. As you can see, it says x is neither 1 nor 2. So pretty neat and pretty kind of like quick. If you want to create the same thing with if, you have to do kind of like 2 ifs with an if. So basically it's going to be like if x equals 1. Actually, let me just go ahead and write it here for you so you see the equivalent. So it's exactly like I say, if x equals 1, then cout, and let me just do my cheating method here. So it's going to do that. Then I'm going to do else if of course I have to check if x is 2 at this point. Then I will be couting this guy. And then finally the final else will be neither this nor that. Oh, sorry, my bad. I have to get rid of this guy. Okay, so pretty much this guy is done. Let me just pull this down a little bit. So these two right now, like the entire switch block over here, is equivalent to the entire if then else block back here. Okay? So the switch statement has a somewhat peculiar syntax inherited from early times of the first C compilers, because it uses labels instead of blocks actually. As you can see, there are labels over there. Each case is a label, right? In most typical use, this means that break statements are needed after each group of statements for a particular label. If break is not included, all statements following the case, including those under any other labels, are also executed, which is not what you want. And it goes until the end of the switch block or a jump statement, such as a break, is reached. If these examples that I showed you lack the break statement after the first group of case 1, the program would not jump automatically to the end of the switch block after printing x is 1 and would instead continue executing statements in case 2, thus printing also x is 2, and it would then continue doing so until a break statement is encountered. So break statements are very, very critical and important when you use the case or you actually are not getting a good logical output based on what you decided to do. So notice that switch is limited to compare its evaluated expression against labels that are constant expressions. It is not possible to use variables as labels or ranges because they're not valid C++ constant expressions. So you can never say case y over here. So this is going to be an error for compiler and it's not going to accept it from us. That's kind of drawback to it. You always need to have a constant over here. So this video reviewed what we wanted to be statements and flow control.